Welcome friends. Welcome to another session on PostgreSQL. Earlier we had seen several PostgreSQL table examples. This is also one of them. I mean, this is a very introductory level. How to create database, how to create tables, how to create indexes, how to create efficient queries, how to create, how to join, how to update, how to insert, how to delete records like that. All these things we'll be going through this. It's a very simple one, but we'll covering lot of data types here, including varchars, integers, dates, etc. So this will be very useful. Please, actually we'll be creating a database. So you please don't forget to like, share, comment, and subscribe. Okay. Earlier videos, some of them are doing very good, and thanks for all that. And we will start this. Okay, to create a database, we will be using create database name. This is the first one. That is sample is the database name we have created. We are using that here also. We create a sample database sample, and then we actually use that here. Okay, inside that connection. So currently that is not in the scope. We'll be actually going through the creation of tables. What are the keys? Okay, this is the first table. That is the sample names. That is the table name. Serial is the here. If you go through the fields, this is sample create table name. Okay, then there is a field name. We given the field name, first field name as ID. This is the data type, that is serial. Serial is actually an auto increment type. Okay, we don't have to give anything there. It will be automatically inserting values. Is behind the scene. Actually, it is a sequence. So it is a primary key. We given it as a primary key. ID is a primary key we given. Next field is first name, and it is varchar. Maximum we can give is 255. Okay, last name is 255, and everything we are given as not null. Age is integer, not null. Date of birth is date. Okay, again we go through a table. Next table is actually sample address. That is, one person can have multiple tables. This is foreign key. It will be having a foreign key. ID is actually, this ID is different from the previous ID. This is ID of sample address, and the name ID actually references this particular ID. Okay, name ID is from the sample names ID. Therefore, references sample names ID. This is the reference. So there will be a referential integrity enforced by PostgreSQL. The address is actually test. This is another data type we are using. It is almost same as varchar, but we can insert the new line character also. Then it is state is there. It is again varchar is there. It is it's also not null. Zip varchar not it is a zip code is also varchar, and country code is actually character of 2. That is actually 2-letter codes of countries. Again we create a third table that is also having internal foreign key relation. So this references again the names table. Sample names table, sample telephone references sample names table, and is ID. Okay, since it is primary key, sir, the serial primary key here. All the three tables are having serial ID as serial primary key. Okay, data type is serial, and it is primary key, and the last two tables actually references sample names table. So here we can see telephone number is there, then the country code, that is ISD code is there. Everything is not null. Okay, then it is actually when we create the index, it is having So when we look at the again when we look at the syntax, create table name within the bracket, that is we give everything is within the bracket, and it is like that. Again, next is the create index is there. Index is actually used to speed up a query. If we don't have index, I mean, if it will be searching each and every record for a particular one until it finds one. I mean, the search is actually, search time actually increases. If we create an index, search time decreases. Those people who are familiar with the computer science field will know that. Here what we create is names, idx, sample names of first name, last name. Again, in this also we have in the first name we can give modifiers as ascending, descending. By default it is ascending always. If we want to give descending, we can give a DESC as modifier. That means it will be everything will be indexed in descending order. That is the first IDX, that is first name and last name based indexing. So next is we create index on date of birth. You see, let's create index name on table name, field name, comma field name. Again it is table name, field name. Again it is age IDX Z. That's a table name, field name. Age is field name, date of birth is field name, first name, last name is field name. zip IDX again it is on sample address. So it is on the zip is a field, sample address is a table. This is the zip IDX is the index name. Create index name on table field name. That's how it is given. Again country IDX is there. So what will be the use of all these things? If you want to search by first name, you can do that. First name and last name, you can do that. Date of birth, you can do that. Search by date of birth, you can do that. Search by age group. If you want to find all people who were born between certain date, you can give that. If you want to find all people of particular age, you can do that. If you want to find people who have address zip codes, a particular people of a particular zip code, you can find that, or people of a particular country, you can find that. Is the country IDX, sample address, country code, it is there. Then again you can give ISD based searches is there. So if you want to find who are all having ISD code, who are all from ISD code US, or who are all from ISD code India or UK, they can find it. Okay, then we are inserting certain data. This is how we insert data. Inserting data is actually you can give multiple values there, but we are giving single statements for each every insert instead of giving all the data together. The first name is there, last name is there, age is there, date of birth is there. So values, first name, that is in the first row it is Constantine Stanley, age 49, 73, 80860, and Lionel Messi, it is 87, 0624. Like that, we have given 3 data there for the sample names data table. Again, sample address, we have given some data there. Sample address is there, and then we give us sample telephone. Every data is given, but country is only one, that is US. Again, the sample telephone number is there. Okay, we given 2 telephone numbers and 2 addresses for each, because it is one-to-many relation is there between sample name and sample address, as well as sample name and sample telephone. So if you want to select any data, or if you want to select a sample, if you want to give select all data from this particular table, you can do that like this. Or we can see that there is 3 different tables that records there. with the date of birth, the 4936, like that. Again, if you want to find, we have given an index layer, so if you want to find by index, you can give like that, first name index. Okay, Lionel. So if you want to update anything, if you want to update age as 35, you can do that. Okay, as you've already seen that Messi is having ID 2, so that's why I have given search ID 2. This is the primary key. Okay, the data has been changed, and if you want to delete any data like this, you can do that. I am trying to delete crick here with first name. I deleted. So if I am again going and searching, the crick record will not be there. This is the two records there. So if I want to insert it again, I can do that. Okay, it is inserted. If I want to find all people born between two dates, that is 77 January 1st and 88 January 1st, you can find it like this. Then select star from sample names where date of birth between, that's it, because it is the data, we can give like this date, we can give like this between this is the syntax for that, 7711 and 8811. What happened? Yeah. So we are actually joining all the three different tables together. Here what we do is we create table alias. We select from table. We created sample names table. From that we make a alias sn and left join that on SA, that is sample address, using sn id equal to SA. As I told you earlier, there is a foreign key relation between sample names, sample addresses, and sample names, sample telephone. Okay, so we are left joining sn.id equal to sa.name id, and left join again that with sample telephone st on sn.id st names.id, that st is alias for sample telephones. And again order by is actually by date of birth descending. So you can even create views on tables or queries. It's actually very simple. Create view name. Example view view. Okay, this is a simple example as select star from sample names where any first 70 and a simple filter. Here create view name as these are the syntax used as after as we have to give the query. Now please hold on. There was some issue with the PG admin and it shut down. So I'm restarting the PG admin. Okay, so again we are trying to create the view, and yeah, actually we created the view, and if you want to see this filter working, we have to use select star from VQ. Okay, so these are the two. These two rows are actually between 70 and 80, and Messi is actually 87, I think. So that's not given. Okay, thank you, friends. Please try to share, like, comment, subscribe, and keep our channel up. Please feel free to ask any doubts. I am always helpful for any people who is having doubts. If you have any projects, please contact me on database side. I mean, if you have anything like migrations, I am a consultant. So please feel free to contact me in any case. Thank you.